we understand. Congruent figures are same size. You need to know the difference between congruence and similarity. Similar figures are proportional. Okay, so basically their angles are the same. The size of the lengths of their sides are different, but they're all proportional. So this is how you use proportions to help you figure this out. So example 1, I got 2 examples for you, and then we'll be done. Here is a small triangle, 3, 4, 5 triangle, and here's a larger triangle, and we are saying that it is similar in size, which I didn't draw it very well. This size is X, that's 6, and that's Y. What's important here is that when you set up your proportion, you need to be focused on which sides match up to the sides of the other figure. And sometimes they like to rotate the object to make you think something different. So be very careful when you're doing some of these problems, is that you match up the correct sides. So here's how I wrote this. Basically, this small side I use lowercase letters. This side I'll use uppercase, just to show you what I'm talking about. If I want to use this base here, and I want to say that base is to the larger base, that bigger side, so all capital letters here, then this fraction in the proportion better be the exact same type of thing. Meaning I went from the small figure to the large figure here, I better go from the small figure to the large figure here. But what I don't want to do is go base to base and then hypotenuse to base. Meaning everything has to correspond. This base is attached to that base. If I want to do this leg, then I better use that leg to correspond with it, which is what? X, right? So corresponding parts are extremely important. Same thing with this hypotenuse. If these are right triangles, this is the hypotenuse. I better use the hypotenuse to go with it in the exact same fashion. I would not go base to hypotenuse and leg to base. You all get that. They must match up. Now, what you asked yesterday, could you go base to leg and base to leg? Certainly. So here's how this works. Let's go ahead and set this up. First we'll start with this. The base to that base, 3 to 6, let me write it below it so you can see it. 3 to 6 is equal to this leg to that leg, 4 to x. Now it's a proportion, everybody could solve for x, right? Cross multiply to get your x out of your denominator. But also you could, to get y, you need the hypotenuse to the hypotenuse. But remember, go the exact same direction. Now you can't solve this proportion. Why not? Yeah, two variables. Whenever you have more than one variable, you can't solve it. Okay, so you need to solve this one first, and then you can solve that one. Or you can set this first ratio equal to that last ratio and solve that proportion. Do you all understand that? You can only have one variable in your equation if you're going to solve it. Okay, and I already addressed going the other way. You can also do this. There's another way to do this. I could go leg of the small figure to the base of the small figure, provided I go the leg of the big figure to the base of the big figure.
Is there going to be?
You don't have to go from small to large every time. You can do 4 is to 3 as x is to 6. It will be the same. So whatever's comfortable for you is fine. Because I've had students do it both ways. Yeah.
Is that going to be easier, or
it doesn't?
Is it going to be the same?
It really comes down to what you see first to be the way to get it done faster. And it's all different for whatever student is doing it. Okay. So anyway, what's the answer for x and y? Everybody figure that out while I'm setting up this next one. Figure out x and y. What's x?
8.
X is 8. Min, what's y? 10. Who has x equals 8 and y equals 10? Okay. I know you guys have done this before, it's still a review, but need to work it out. Now, before you even start this, what's the easy answer? Which letter is the easiest to answer right now? On example 2.
X.
Wrong. Who said x? It's wrong. Who said y? Y is y, Reggie. Yeah, these are, this is an isosceles trapezoid. So if these two sides are the same, then these two sides have to be the same. If they're proportional, and you're to assume these are proportional because that's what we're working on. So y is automatically 7. You don't even need to set up a proportion. All right, so go ahead and solve for x and z. Everybody set it up. Figure it out. Make sure you use the corresponding sides. It is turned around. When you're done, raise your hand so I know. I went ahead and set up all ratios equal to each other. Obviously, you're not going to do that. You're going to do 2 ratios, set up a proportion, cross multiply. So, what's x?
14.
X is 14. We already have y. Y has to be 7. And then you set up the other proportion. Min.
Z equals 3.1.
Who else has 3 1/2? Because you didn't use the calculator. I don't see any decimals up here. Who had 3 1/2? That's right. Okay. Any questions? That's it. Can you do this?
Yeah.
You ready for your big assignment?
35.
Who said that?
Nobody?
Nobody?
I know
Let me look at. All right, they're done.